Welcome to the Biomaterials Lab. Safety is our first priority, so please ensure to wear personal protective equipment on you, which includes the lab coat, safety glasses, and gloves. For further safety information, please visit safety.rice.edu. Before powering on the equipment, remove the bottom cover plates and hold the top cover plate and unscrew the down rod from the top. Turn on the equipment by pressing the power button. Now the display on the rheometer will be turned on. Turn on the chiller below the equipment down here. Choose the appropriate geometry for your experiment. We have a 40mm, a 20mm, or an 8mm diameter Peltier flat plates. Slide the geometry and align the notches on the geometry and the rheometer. Push the geometry from the bottom and tighten the down rod from the top. To launch the application, click Trios. Click on the correct instrument, which is the Discovery Hybrid Rheometer 2, and then click Connect. This is the default interface. On the left, you have File Manager, where you can set up your experiments, look at the results, select the geometries and calibration. In the middle is your experimental setup. On the right is the control panel. If the control panel is missing, you can click on the controls here to get back the control panel. In the experiments, you have an option to clone your last experiment or start with a new default experiment. I'll start with a new default experiment. Click Yes. In the sample, enter your sample name. Add date for identifying what sample you have run. The operator will be you, the user. The project and notes are for your information to identify your sample later on. Click on the file name and click on these three dots to choose where you want to save your data. Go to Libraries, choose Documents, go to My Documents. Create a new folder with your name. And hit OK. The next segment is the geometry. The rheometer automatically identifies the geometry that was installed, which is the 20mm parallel plate Peltier plate steel. The gap is the gap at which you want to do your experiments. And the loading gap is the gap between plates for you to load your sample. Trim gap offset is the difference between your experimental gap and the trim gap. You can get an estimate of volume that is needed to run this experiment. As you can see, it is very small volume. The next tab is procedure. You can delete this default step and add a new default step. You can add multiple steps if you want to perform different type of experiments. For now, I will choose a simple experiment to determine the viscosity of the liquid. From drop down, you have an option to choose oscillation, flow, step, other, or conditioning. I will choose flow. There is one more parameter that you can change to get more data. I'm going to sweep with the flow. You can enter the temperature at which you want to perform the experiment. With the chiller turned on, it ensures the experiment is run at the same temperature throughout. Here, you can choose either shear rate, angular velocity, stress, or torque. I'm going to choose shear rate. I'm going to enter 1, I want to test the viscosity with a shear rate of 1 to 100. You can change these values depending on your experimental needs. You can click on Save to save your protocol. You will browse to your folder and save your protocol. To load your sample, first we need to zero the gap. Now the rheometer moves the upper shaft until the gap between both of them is 0. The gap value changes once both the plates are in contact. Once the head zero is completed, you see this pop up and hit OK. Now we move plates to loading gap. Load your sample between both the plates. If the gap is too tight, you can move the plates apart by pressing the upward arrow here. Add your sample to the center of the plate. Click on Go to Trim Gap. At this point, you should see your sample squeezing out between both the plates. Please be patient, as it may take a while to get to the trim gap, which is set to 350. You can see the gap between both the plates is 600 something right now. Trim off the excess material along the edges. Once the plates have reached the trim gap, click on Go to Geometry Gap. Again, please be patient and make sure the gap between both the plates reads 300 microns or whatever the value is set to be the geometry gap. Once the geometry gap has been achieved, click Start to run the experiment. The graph is plotted and the data is collected as the experiment progresses. Values of multiple parameters are collected as the experiment progresses. If more parameters are to be collected, click on Select, choose the new parameter, and click OK. Note that even if a parameter is not shown in the table, all values are collected by the system. To change the graph, double-click anywhere on the graph. Choose the axis and click the variable that needs to be plotted on the graph and click OK. The progress of the experiment can be seen here. And as the experiment progresses, the graph is updated. Now the experiment has ended. As you can see, the graph is plotted and you have your raw data for further analysis. Click on Trios and click Save to save all your documents. Click on Trios one more time and export to Excel. You get an option to choose what needs to be exported. Hit OK. After the end of the experiment, you can save your data as an Excel file. You can click it, close, and you can navigate to your folder just to make sure you have all your data. your sample data and the trios files for your experiment. After saving your data, you can close out by hitting the X and save all. After completing the experiment, jog the rheometer up to remove the geometry. Pull the geometry from the bottom and turn the shaft on the top to loosen the geometry. Clean the surface of the geometry and the plate. You may use appropriate solvent to remove any residue. To shut down the equipment, press the power button and turn off the chiller. Install the bottom cover plate, and for the top plate, push from the bottom and tighten the down rod from the top. Do not over tighten. A couple of turns is good. For further information or questions, please contact the Biomaterials Lab Manager.